Alright, we're going to continue here with accuracy of the averages. Here's another problem. A survey is conducted to determine the number of devices connected to the internet within households of a certain city. Let's assume here that the survey organization does a simple random sample of 2,500 households. The average number of devices connected to the internet was 5.75 devices, with a standard deviation around 2.5 within the sample. Estimate the average number of devices connected to the internet within the households of the city and attach a 95% confidence interval to your answer. So yes, there are a few typos in that problem, and that's because I wrote it myself. But what I'm trying to get at here is we have this box, and we have a sample from the box. The sample is 2,500 people, and we know about the sample. We know the average within the sample is 5.75, and the standard deviation is about 2.5. What we don't know is the contents of the box. So this is an example of reasoning backwards. We've seen one example like that in the other videos. So what's challenging here is because we don't know the box. We don't have an expected value. Instead, we'll use the average from the sample as an approximation. It will be the center of our estimated histogram. We still need to find the standard error. The formula for the standard error is the square root of the sample size divided by the sample size times the SD of the box, which once again I'll rewrite as the SD of the box divided by the square root of the sample size. You can check these answers will be equivalent no matter which formula you use. Well, the problem is we don't know the SD of the box. So we have to use the bootstrap. Method, which says instead of using the SD of the box, because that is not known, we use the standard deviation of the sample, which we do know it is 2.5. So we take 2.5 divided by the square root of the sample size. The sample size was written here is 2,500. So let's plug this into the calculator. I'm not entirely familiar with this. Let's try this. That didn't work, but that will. So getting 1.58, but I want to double check that because it should be 2.5 divided by 50. Is 50 times 50 is 2,500. So let's double check the answer here. So you have 2.5 divided by 50, and that's 0.05. So I'm not sure what we're calculating here, but this is wrong. So that's the standard error. So now we're ready to answer the question, which is estimate the average number of household devices connected to the internet. Our estimate would be the average in the sample. So we'd estimate the average number of devices connected to the internet is 5.75. I know that's not a whole number, but it's an average, so it'll work. And we want to attach a 95% confidence interval. Now 95%, we're looking at the area column here. If we go to the closest number to 95, that's 95.45. That's associated with z equals 2. So what that translates to is that we want to go plus or minus 2 standard errors from the expected value, well, from the estimated average. 2 standard errors is 2 times the SE, which is 0.1. So what we can say is we can be about 95% confident that the average of the box of our population is between, we take the 0.1 subtracted from 5.75, so that would give us 5.65, and take the 5.75 and add 0.1 to get 5.85. So to read that whole sentence, we can be about 95% confident that the average is between 5.65 and 5.85. If you have any questions about this video, please ask in the questions and answers discussion board.